So you'll be knowing the current, that is I, inner potential electrodes V. So we know Ohm's law, very famous law, which is V equal to IR. So V is potential difference, which I get, and I is the current electrodes, and the ratio of these two, V by I, which gives you R. So that is our resistance. So this tomography, what I call as ERT, electrical resistivity tomography, is a mission. I'll show you. This is the mission. You can see this. This is a type of ERT from different manufacturers. So this is a ERT mission. This mission will record the output potential difference, and it will note the input provided current. So it will automatically do the calculation part. That is, it will convert V by I, which gets R, that is resistance, and later it will be converted to resistivity. So I think you know the difference between these two. So resistance is a phenomenon in which current will be opposed, like flow of electrons will be opposed. That is resistance. Whereas resistivity is a property of a material. Like each material will have different values of resistivity. Coming to the last one, tomography. We'll see what is resistivity in detail. Tomography. So I think many of us are very aware of CRT, the all scanning missions, right? So tomography is nothing but it's a device which will be sending some waves, especially penetrating waves, in the form of X-rays or ultrasound waves, some sort of waves. It can pass or penetrate into the ground, and finally it can give a cross-sectional view. So if you see properly, tomograph is a mission which will be sending the waves, will give an input. This input will be in the format of resistance. So coming to this, there are two types of resistivity. One is true, second is apparent. Please try to understand this mission tomography will only focus on providing apparent resistivity. It don't give any true resistivity. So what is the difference between these two? So nothing, very simple. Apparent resistivity is defined as true resistivity into some K, which is called a geometrical constant. You can see the last point. Apparent resistivity is obtained as it's a product of true resistivity and with a geometrical constant. I will discuss what is geometrical constant in detail when I discuss about array system. So coming back, the main motto of this tomography device is to give the value of apparent resistivity. As I'm discussing here, the current waves will be passed through the soil. As we go deeper into the soil, different type of soil stratas are observed. So each soil strata will have, sorry for a disturbance, I think. So each soil will have different resistivity values. We'll see that. So you can see here, like rocks, rock is very bad conductor of electricity. Like it's very high, possessing very high resistivity value. If you see this trend, igneous rocks will have high resistivity compared to metamorphic rock and compared to sedimentary rocks. So if you see this diagram, this is a code from ASTM. So this code gives a glimpse of the readings. You can see a different soil status. On your top y-axis, it is resistivity, and you can see bottom, it is conductivity. Opposite resistivity is your conductivity. You can see it's very crazy to understand the difference between C and I's. You can see seawater possesses higher conductivity compared to ice. The same way graphite, igneous rocks, gravel and sand. You can see clays. Clays are having very low resistivity values. You can see it's moving towards left side, whereas gravel and sand are having high resistivity, followed by rocks. So if let us see the glimpse, current will be sent to outer electrodes. Inner electrodes will detect the potential difference. Using Ohm's law, we'll be getting a resistance value, more precisely a resistivity value. Each kind of soil will have different resistivity values based on which we can make a comment on the type of soil, what kind of soil is present below the ground. So this ERT is having vast applications. To list a few, one is detection of groundwater, like where is groundwater starting, where it's going to end up. Overburden thickness, more precisely, what type of soil status are present. Location of faults, as well as dikes, seepage zones, of course, aquifer, almost like groundwater table, maybe confined or unconfined aquifers. Finally, it's a part of environmental as well as hydrological investigation. Moreover, in addition to this, we can use to detect the presence of cavities also. So coming to the next topic, that is arrays classification. What exactly is an array? So array is nothing but the pattern or the way in which the electrodes are arranged. Like if you see this one, you can see there are 4 electrodes which are aligned along a straight path, like collinear. So if I jumble the position of current electrodes or potential electrodes, how the arrays will be changed. So briefly, there are so many types of arrays, but civil engineering point of view, especially geotechnical point of view, there are 4 major electrodes arrays. One is Venner, second one is Schlumberger, third one dipole, and fourth one dipole. Sorry, pole to dipole. We'll see each and everything and discuss in detail. First one is Venner array. If you see this diagram keenly, A is electrode, B is electrode, like extreme electrodes, which are said to be current electrodes. M and N are inner electrodes, which are called potential electrodes. If you see the diagram keenly, the spacing between all the electrodes are uniform. A distance of A. A can be 1 meter, 0.5 meters, 2 meters, 10 meters, 20 meters. It varies. If the spacing between all the electrodes are uniform, then it is said to be a Venner array. Like electrodes are spaced uniformly. As I discussed already previously, so apparent resistivity is defined as the true resistivity value with a geometrical constant. So what is a geometrical constant? If you see Venner method, the geometrical constant is defined as K is equal to, the geometrical constant K is equal to 2 is the number, pi into A, where A is the spacing between the electrodes. So when should I go to this type of array? Especially Venner array is used to do a lateral soil exploration or investigation, because you can see the soil present at here and the soil present within 1 kilometer radius will vary. So if you want to study the lateral variations, then Venner method is recommended. Of course, Venner method is also recommended for places like urban areas where you have huge noise disturbances. The next method is Schlumberger. If this is Schlumberger method, same story. A and B are current electrodes. M and N are your potential electrodes, and the spacing are no more same. M and N are a different spacing, and A and B are a different spacing. And geometrical constant K is defined as pi into L square. You can see what is L. half the like AB by 2. AB is the current electrodes, the distance half times into 2L. L means small L indicates the spacing between the inner electrodes. Generally, AB is kept at a distance of greater than 5 times Mn distance. So this distance times 5 times gives you AB. So this method is used for a vertical exploration, that is going deep into the ground, deep into the soil. Array is lateral exploration, Schlumberger is vertical exploration. Many of the geotechnical investigations recommend Schlumberger method because it consumes less time. Moreover, the second reason is that M and N are fixed for some point of time and AB goes on changing. But if you see array, every time to maintain the constant spacing, if AB are to be shifted outward, then M and N also should be shifted outward to maintain the same spacing. So next is dipole. So if you see dipole, at one extreme, current electrodes are provided. At other extreme, potential electrodes are provided with a uniform spacing of A. And the distance between these two is N times A, where N is always recommended to be integer, provided to be integer. So this is also used to explore much more greater depths. Especially this is used for 3D profiling. I'll discuss in coming further slides. So the biggest advantage of this method is that these two cables, like these two electrodes, are to be connected, and these two are to be connected. So it requires a shorter cable length, and especially this, like the K geometrical constant form is different as like this: pi into n into n plus 1 into n plus 2 into a, where n is nothing but this, the manifold number. And this method is recommended to explore the direction of dip. So the last method is pole to dipole. Of course, it is also 3D method. In this, you can see potential electrodes are placed at one side. Current electrode 1 is placed at one side, and the other one is placed at a distance of infinity. So this is recommended. So this is recommended. Am I audible?
Yes, sir. Yes, sir.
Okay. So pole to dipole. Coming to this. Okay, coming back. So sorry for the small disturbance. So coming back. So pole to dipole system. This is generally recommended when you want a better quality compared to dipole. So the next is about imaging. That is, you can see if we're coming in a trend, the first one is about placing electrodes after fixing a kind of array, maybe a Werner array or Schlumberger. So first, the investigator has to fix the kind of array. Like I want to do a lateral exploration, then I'll go for Werner. Or if I want a vertical exploration, I'll go for Schlumberger. Once my array is done, so I'll fix all the electrodes, and these will be connected to my, which I showed you already, resistive that is tomography. I'll connect to my tomography. Then I start taking my readings. So once the readings are ready, you get this type of diagrams. So there are three kind of patterns here in detail. The top one, which I'm showing right now with a laser point, is called VES, which is vertical electrical sounding. In simplest language, it will give you one-dimensional view. You can see this diagram. Of course, I'll discuss in detail later. So this is vertical electrical sounding. which gives only 1D view. So next one is electrical profiling. You can see this. So this is a 2D profile where you can see the spacing or the horizontal distance as well as the vertical distance. Like I'm going to the below the ground surface. The third one is the most sophisticated one, that is 3D imaging. You can see both all the three dimensions, x-axis, y-axis, and z-axis are shown. Of course, it is most accurate, but it's one of the complex method. So coming to the first method, vertical electrical sounding. This method is also called as expanding probe method. Like this method will require or will demand only 4 electrodes. That's the only difference. That's one of the difference between all the 3 methods. This type of imaging can be obtained using 4 electrodes, whereas electrical profiling as well as 3D resistivity or 3D imaging requires electrodes more than 25, sometimes 120, 180 also, it depends. The procedure is same. Like what the software will do is that, for example, let's go to electrical profiling. Let's make very simple calculation part. There are 30 electrodes. Sorry, 28 electrodes. If there are 28 electrodes, we want only 4 electrodes. That is 2 current electrodes, 2 potential electrodes. Now, the software will arbitrarily assign some electrodes to act as current electrodes, some as potential electrodes. Like it will do a zigzag method. The same with 3D resistivity method. So it will compile all the data. Finally, it will generate this type of report imaging. So if you focus on this vertical electrical sounding method, 4 electrodes are enough, and this type of images will be observed. Like in this expert talk, I'll be discussing this entire method, how to develop this model in detail. 2D as well as 3D is beyond the scope of this lecture. So as we go further, I'll discuss in detail. Let's go on electrical profiling. If you see properly, different color palettes can be observed. And at the bottom, you can see a scale showing the value of resistivity. To make it simple, a color of blue is around 250 ohm meter. So wherever you see blue color, it indicates 250 ohm meter. So 250 ohm meter can be any type of soil. It can be clay, it can be sand. So you can see the depth here also. From ground surface to a depth of 38.7 meters like that. It will show roughly is clay with a merge of sand like that. But if you see here, maybe a brownish color, which shows a residual value of 1000, which means it can be a rock, or sometimes it can be a sedimentary rock like limestone. Same way, you can see a sky blue color. Generally, sky blue is for indication of water. Same way with 3D resistivity. Of course, as I already discussed earlier, 3D resistivity, we can't go for Werner and Schlumberger. The only methods recommended are dipole, and pole to dipole. So the last is your data interpretation. So like it's all stepwise. First, we arrange electrodes, we pass the current, potential difference will be noted, and resistivity value is calculated. It will be converted into apparent resistivity, and we have to feed this data to the system. It will generate a plot. But this is the recent advancements after a high fasting systems, like the fast computers once came into the world. It's very easy to generate. Before advancement of computers, they used to go for curve matching as well as auxiliary point method. It's very tedious, but a lot of things can be explored. So data interpretation, like how you extract the data, what you get from the data, can be done in 2 ways. One is curve matching and an auxiliary point method. Second one is inversion method. Coming to curve matching as an auxiliary point method, in this method, we go on plotting the graph. Now it's very important to understand. especially log-log graph will be plotted. You can see here. So the graph which are obtained between apparent resistivity value with spacing. Here spacing implies AB by 2. You know what is AB by 2? So AB is nothing but this is AB. That is our outer current electrodes. So AB by 2 means half of the distance is called spacing in this graph plotting. So apparent resistivity graph is defined as a graph plotted between apparent resistivity value with electrode spacing. Electrode spacing means AB by 2. So if I want to see 1D imaging, 1D graph, that is vertical electrical sounding, then it recommended a double logarithmic graph. That is, you have to plot log-log axis. If you want profiling, that is 2D imaging, we go for semi-log. That is, x-axis will be semi-log, log, y-axis will be arithmetic scale. So if you see this graph, so these all are an examples of your apparent resistivity curves. If you see, all graphs are showing the same thing. Your x-axis is AB by 2, which we say as electrode spacing, and y-axis is called apparent resistivity. I told you true resistivity with a geometric constant, which depends upon the type of array. So if you see, this type of graph is called A type. This is called H type. This is K type, and this is Q type. What's the difference among these three? So to understand, let's see an example. For example, this is my ground surface. This is one soil. This is second soil, like third layer. So for example, this is my ground surface. So this is like strata 1, this is strata 2, and this is strata 3. So each strata will have different type of resistivity values. I assume this is row 1, this is row 2, and this is row 3. So if you see graph 1, that is A type, if row 3 proves to be highest value, if row 3 proves to be highest compared to row 2, compared to row 1, then this type of graph which you obtain is called a type. The other way, if row 2 found to be higher than row 1 and row 3, that is called H type, which you get this type of this pattern. Sorry, row 2 is the minimum. So row 2 is minimum compared to row 1 and row 3. The other one, row 2, that is the resistivity value is higher for second soil layer compared to 1 and 3, then you get a K type, like this one, this parameter. The last one is Q type, where row 1 is the dominating one. Row 1 is highest value compared to row 2 and row 3. So A means row 3 is highest, Q means row 1 is highest, K is row 2 is highest. So by seeing the graph pattern, you can simply make a comment on the type of soil strata. Of course, this is a tedious process because you have to plot a log-log graph. You have to understand the log-log graph, and plotting the log-log graph will take more time. And moreover, it's a very tedious process. So with advancement of computers, especially fast computing computers, now the world is shifting towards the third method, which is inversion method. Simplest terms like reiteration process. So in inversion curve, compared to inversion, you have to just enter the data into the system. System will give, like system starts computing, and you just get the output. Like if you see this diagram, you can see this type of trends can be generated by the system automatically, provided you have to compute properly. So if you see this graph, like same like curve matching, same way, apparent resistance on y-axis and your electrode spacing AB by 2 and x-axis, same plot, alpha spacing on x-axis and resistivity value on y-axis. But remember, it is log for vertical electrical sounding approach. So here what we do is that if you see the curve with a circles dotted pattern, this is the readings which I get from my testing. Whereas this layer model will be computed by the system. Now the computational person should ensure that the observed graph as well as the theory graph should match. That is what we say as inversion. Like he has to do so many iteration process, so many repetition process until he matches his observed curve with the model graph developed. So this is the software which I'm going to discuss in detail. Of course, I'm not discussing all patterns. I'm discussing all important things that I have to be make a note. So before I start this software, so let's go back. If you want to develop a model, 1D model especially, that is vertical electrical sounding, then the software is freely available in Google. You can download. Like Interprex is one software. There's so many softwares. You can download Interprex directly. It's a free software. Whereas coming to 2D and 3D, especially for 2D, there is one software called Res 2D in. Better make a note. I will write here. Resistivity 2D. It is INV. In this is one software which can be used to plot a graph of 2D. Compare when you go for 3D, same with 3D inversion. This is one more software. Whereas you can go for Interprex for 1D. So the 2D and 3D are not free versions until I know. So you have to purchase. So as this is free version, like Interprex, so I'm discussing this in detail. So Interprex, this is 1D. I told you it's only for 1D imaging. So as soon as you download and open the software, this is the home screen. This is the home screen you notice. There are two graphs here. Of course, both are log-log. You can see log-log, and this is also log-log. So this graph will indicate, will show you only electrical sounding system graph. This graph is called apparent resistivity curve. Coming to this graph, this is called a model. This is called a model. So this shows you like x-axis is resistivity value, y-axis is depth. So when you compare to this electrical sounding graph, apparent resistivity curve, x-axis is spacing, y-axis is apparent resistivity. So you have to do both the graphs. So step number 1, you click on the file, or you can use this for this is to create a new vertical electrical sounding where my cursor is pointing out. This is for model option, or you can simply click on file. You can see here, you get a new, go for sounding. If you want to generate a graph on sounding, if you want to generate a model, click on model. It's up to you. So let's go for sounding first. So click on file, new, you get sounding. Sounding, you have so many options: DC, resistivity, IP, IC for induced polarization, maximum sounding, EM, electromagnetic MT. There's so many options. But as this talk is confined to resistivity sounding, so I'm discussing only the first one. DC means direct current. So once you select sounding, DC resistivity sounding, you will see a new like a window open. So which shows array type. So what kind of array you performed on the site, you have to select maybe Werner or Schlumberger, dipole, pole. And type of data, like what kind of data you're having. Are you having apparent resistivity values? Then you select this checkbox. If you have voltage and current data, you can select this. Then press OK. Next, you get this type of window. So I selected apparent resistivity value. So I got this type of window. So you have to enter your data from some name, file name, northing and easting. If you know these dimensions, you have to enter. It is recommended to enter always. Units you can change. Now it is showing Schlumberger because I selected Schlumberger here and I selected apparent resistivity. So I'm getting the same. So you know what is AB by 2? That is half of the distance of current electrodes. Enter the data. It's just a rough and rough data entered. This don't assume it is correct. And Mn, you know what is Mn? Mn is the distance between the inner electrodes. You can see this diagram. Yeah. So AB is the total distance. AB by 2 is half. Mn means the internal distance. So you should note these values to get this graph. So AB value are entered. AB by 2 values are entered. Mn values are also entered. Apparent resistivity you have to enter, which will be shown by the system. You have to enter. And mask. I'll discuss this in detail. What is a mask and what is a fix here? So this is one of entering manually. If data is too large, if you feel like I showed you 12 entries, like if there are 20 or 40 or 100 entries, you can take entries of 1,000 entries. You can take 1,000 values. So if you feel entries are too much, then you can simply import. I think I didn't show you import one. Okay, anyway, you have input option also. Okay, in file you can see if you go down, you have input option also. You can directly import the value. Or if you have Excel sheet, you can copy and paste, as simple as that. So open geometry, save geometries, I think it's very simple to understand. Like open geometry, it will open the entire data. We'll see at the after this. Save geometry to save the data. If you want to rename, you can go for this. Insert cell, you know how to, like if you want to add one more cell, you can enter, or you can delete same rows and multiply by, add to this mathematical calculations. If your data is good, no need to do these things. If you feel there's anything wrong, went wrong, then it's recommended to go for this. Then press OK. Comparing to, when come back to this, like this window is showing sounding, that is profile of vertical electrical sounding. In case if you want to develop the model, same procedure, click new, click model, then you get this type of window. You can see here on the top, this is apparent resistivity, that is sounding. This is a resistivity value, that is your model. In model, you have to enter row values. Like I just copied and pasted the same values here. It will little bit change. No, almost same values. Thickness, you know what is the thickness? Means thickness of each like solid strata. So system will automatically cumulative this depth. You can see ground surface is 0. From ground surface, if I go 1 meter below, I'm getting a row value as 159.9. If you go a depth of 1.4, so the total depth is 2.4. That's what here it is showing. So it's a cumulative. Elevation, you know, the reverse of depth is elevation. It is making a note of this. So once you enter the data, you can click OK. So this is a resistivity value. I enter all the data. I click OK. Then these are the points which I obtained. You can see it is showing me there are 12 points with 12 layers. The bottom, it is showing me 12 values with 12 layers. So you can see there are 12 points. So it just took, and of course it is a screenshot. So if you see the software, if you go to a point, it will show the reading also. Same way, this one, once I click OK, this model will be generated automatically. So this is the, once the points are known, you can see, let's see this window. I'll discuss a little bit. Like you can open a window. This icon represents edit data, especially for sounding curve. If you want to make any changes in the data, you can go for this option. Whereas if you want to make a corrections in the model, you can go for this data. Now next two are zoom in and zoom out. Now coming to the next two are our models. So if you see, So these are layered models. Like if I click on this, I get a layer by layer. It will divide. So this is smooth curve. If you want to see any smooth curves, you can get. So coming to this especially this button, the second one, showing an arrow towards the left side, is called single inversion pattern. If you click on this, it will compile the data. Like I told you, inversion means iteration process. This is multiple iterations. So you have to do iterations so many times till you get a smooth curve. So once you feel your curve is good, you can stop. Otherwise, you have to do the same process by computing so many times. So when to stop this model? Like, is there any technical point? So I showed you here, RMS, root mean square. This is something which denotes your error. So after making so many iterations, maybe multiple iterations or single iterations, after making so many times, you will notice that this number remains constant. So once you feel this remains constant, then iterations are done. Like the graph, you got the plot. Like I showed you this. Yeah, this type of graph is done. Now you have to just check your readings. So I computed, finally I got a reading of 6.44%, and this value remains constant, which means it has did its computation. So if you see this graph in detail, you can see depth is around 1 meter. So 1 meter, you can see the values, resistive values coming to be like this. Same way, like 1 to 10 meters. If you feel like with your own expertise, you feel there is something wrong, then with the help of cursor, you can move this. We can move the sides and make it appropriate answer. So this is about your 1D resistive value. Like it's also a tedious process. Like you have to do so many iterations, and to confirm your answer, it requires a lot of practice. So whereas compared to the other methods, 2D imaging especially, as I told you, there is software called res 2D inversion. This is very easy method. Like it will give everything. Just you have to copy and paste in your report, as simple as this. So this method will automatically give everything. The only problem with this method is that you should be very much expertise with the using of the equipment. So if you see this method, I'll just discuss this in detail. There is some option called pseudo section. So of course, latest trend, like one of the equipment which we're using for this is terameter. Terameter is the device which can be used to get 2D and 3D imaging. So when you go for 2D imaging, that terameter automatically give these values. So this diagram is called pseudo section. So this gives more and clear and elaborate diagram. Nothing to compute and no need to make any iterations. It itself will give the RMS value. You can see like it's, even though it's small, I think you can see iteration 5, it made 5 iterations automatically. No need to do, like we have to give command in 1D for every time. For 2D, no need, it will do, and see the percentage of RMS error. It's going to be 1.5. But if you see 1D imaging, it can be 5 or 4. 5 is the good value. More than 5 you see 7, 8, 6, something like that. You can see there's a lot of error reduced in 2D imaging. And moreover, it's very clean and clear. So this is all about our method. So these are some advancements, like countries like South Africa, like Algeria or Dubai or US, Rome. These countries were using this type of methods a long back ago. This is not a method which is following right now, or this 20th generation or 21st generation. The countries have already used this method a long back ago, but now we are like shifting towards this trend. But still, a lot of things should be explored in this methodology. So not only this ERT is there are so many other equipments are also there, like GPR, which is ground penetration radar, which is one of the good equipment which give you like what is hidden below the soil. There's some other approaches like MSW, SASW. There's so many like advances. So I feel it's one of the good advancement which needs to be learned and to be demonstrated in India. So these are some of the important references. Of course, there are so many other references, but these are some of the, I feel, good references which I've gone through. So we'll see some of the interesting meanwhile, if you don't mind, with the kind permission of the organizers, like you can ask some questions for meanwhile.
So thank you, Mr. Sai Lakshman. Now the session is open for questionnaire. So if anybody wants to ask a question, you can raise your hands. Or else you can post your questions in the chat box also. So yeah, we have one question, Mr. Sai Lakshman.
Yeah.
What is the accuracy of results of electrical resistance method in case of sedimentary rocks?
Yeah, so that's a really good question. So see, first of all, this method cannot be judged directly. Like for example, a new fresher going to the site directly without no experience, and you can do some mistakes. See, the accuracy depends upon the method you're following and the way you're doing. See, the like some code says that there's no need to follow only direct current. You can go for alternating current with a low frequency. This is one trend. So the other trend says that like if there's something structure which is present beside you're performing the test, then there may be deflections that may lead to a problem, or there may be a drainage system which may affect the answer. So it depends your accuracy irrespective of the soil strata. It can be a sedimentary rock, anything. It depends upon the array you're following, the method you're adopting, and it's finally it's a judgmental value. So till now, the various journals or conferences states that the method followed from ERT is fire good, like good. The results are showing very good compared to the other approaches. So both are giving almost same answers. It's not a big deal. Like there is no within the range. I feel the answer is really good because there is nothing which I know there's nothing wrong with that. So all the results are finally good, irrespective of the rock or the soil strata. It's only about experience.
Thank you, sir. And one more question.
Yeah.
Can we go for boreholes and vertical electrical sounding methods instead of going for 2D or 3D modelings? Or which one of it is best?
If you don't mind, can you repeat the question again?
Can we go for boreholes and vertical electrical sounding methods instead of going for this 2D or 3D methods?
So see, what I say is that actually this method itself is a non-destructive method. So I don't want to disturb the soil system. So if you do borehole and if you do 1D, then I think if you want to check, like if you want to validate your answer, you can try. There's nothing wrong. It's a validation. So if your main motive is to validate your answer, then I recommend this method. Otherwise, I think you yourself are doing the double work. Like you're spoiling the ecosystem, like disturbing the soil structure, and also you are doing this procedure.
Okay. I mean, like, so this electrical method is one which cannot be, I mean, much of the soil will not be disturbed. So
Yeah,
you suggest that this is maybe better.
yeah.
So usage of software is compulsory while we are doing this electrical resistivity method, or only without the software usage also we can possibly do this?
See, as I showed in my presentation,
Yes.
just a minute, I'll be showing the presentation. Yeah, I think you can see my presentation.
No, we can still only see the references. Yeah.
Yeah. So see, if you feel I don't want to use any software, the only option is a curve matching method. So you have to plot each and every data on the graph sheet, maybe log the graph, and how to get these curves.
Okay.
It's a tedious work. I know if you feel I don't want to do this because computers are doing everything.
Yeah.
What is the point?
Okay. Okay. So one more question. Is there any instrument for measurement of water level in ground surface?
Yeah, there are so many techniques are there, so many equipments are there to measure water table. I think this method itself will be good. You can see, as I showed in 2D imaging also, you can see this sky blue color, like color palette, which itself is showing you water level maybe roughly. So to know the water table or look, I told you the application of this mission, this equipment. You can see the first application itself is groundwater location. So you can easily detect the groundwater table, as simple as this.
Okay, sir. Next one. Can the electrical resistance method be a complete substitute for conventional soil exploration systems?
Yeah, actually, this is a very interesting question. So if you ask me, it's a complete substitute. I'm talking about India at this point of time. The answer is no,
Yes.
as simple as that. Because still we are not well advanced with using of the software, or we're not keen. Like it requires much more exploring of the equipment. So I think with coming days, I think your answer may be yes. Right now it is no.
Okay, maybe you're saying that this is much costlier.
No. Yeah, that's one of the point. Like it's good advantage actually. Why I'm going for ERT is that it is economy. This equipment is very economy comparing to drilling a borehole and doing the soil testing is more costlier than your ERT. It's a cheap, that is economy, easy, fast, and accurate. So for previous question, my answer is that we are not accustomed with using this mission. That's why right now I can't say ERT is completely substitute. No, ERT can be partially substitute. As time progresses, maybe the answer may be yes. As we are not aware of this machine completely, that's why right now it is partially substitute.
Okay, sir. And like for all the soil conditions, is this method suited?
Yeah, I think the current slide is showing you. So we're showing all types of soil, including the chemicals. You can see sulfates also it can detect, right? So it can be gravel, sand, silty sand, anything. Anything can be easily explored with this type of equipment.
Okay, sir. And like, yeah, the previous person who has asked the question, he is again saying that
Hmm.
can we go for boreholes and horizontal electrical sounding methods instead of going for 2D or 3D moldings? He has just corrected himself, like it's not vertical, it's horizontal.
See, I told you, there is this. Yeah. 1D or vertical electrical sounding is used to give vertical exploration only. It can give a complete picture of soil status in y-axis, like depth. So you were making a borehole, and again you were doing a vertical ERT. And if you want a lateral image, like a 2D imaging, without using this, the answer is no. You can get this answer by using dipole, which gives you only 3D imaging. So for your question, the answer is no. You can do provided if you use Venner method. If you see Venner method, Venner will give you lateral exploration. In same way, you were saying you will be drilling a borehole. Borehole will be vertical direction. Then you may get, but you have to use a 2D imaging software.
So, so the next one,
Hmm.
is this an advanced level, or maybe at a student level, or maybe just above the student level, this method can be used?
Yeah, this is also one of the interesting question. So if you remember when like for BTech students, it is discussed like there's a method something called like this. What's the basic principle? That's what it is written in the textbooks for BTech point of view. But I feel this is an upcoming technology that is irrespective of the age. Like it's only for students or above students or faculty. No, soil exploration is it's an exploration of soil as simple as that. So right now we are not damn sure that the profile you're getting like validation. I mean, my intention is my intention is validation. Like I'll make a borehole, I get some readings, and I have to compare with this technique. If both proves to be same, then I feel nobody's going to recommend soil exploration by some technique because this is very easy, saving time and save the money. So I think this is not confined to any UG or PG programs. If this is going to be a success, a massive success, then everybody will be using this technique.
So is there any relation with the tectonic plates movement or something like that we can observe from
Yeah,
this?
I told you earlier already. So if you see like application third point, location of faults and dikes. So see, continuous observation of movement of tectonic plates is not possible with any of the method.
Yes,
Like
yes.
if I make a borehole and see, I can't see because tectonic plates will move at a very slow rate. So if I do this the same method, like iteration of this method in due course of time, then I may give a rough sketch that the plate is moving, is shifting from one place to other place. But at one time doing the test and giving the answer is no.
Okay. So one more participant named Suhasini is asking one question.
Mm.
What is the name of several softwares used for this, and can we download them freely from Google?
I already told. So 1D imaging is concerned, so this one which I discussed is freely can be downloaded from Google. Whereas 2D and 3D imaging, you can't download freely. It has to be purchased from the manufacturer.
So one more question from Rana Pratap. So will the site studies can be directly taken as a data into the system, or how is it done basically with the with the site data and the system data? How we can match them?
Yeah. So I told you. So this is your tomography mission. So this mission will automatically note I value, that is current value, and potential difference value. It will find R value, that is resistivity value. These values will be stored in the system. Means the software installed within this parameter. This is tomography. So you take a pen drive, you just copy the data and just upload in our or import in our software. As simple as that.
Okay. And yeah, this particular equipment, I mean, if you have any idea, company of the equipment and what might be the average cost or so?
See,
if like on average.
To be honest, I should not say at this point of time because it varies from company to company.
See, no, on average.
I'm telling. It varies from company to company. It starts from 2 lakhs. It will go to up to 60 and 70 lakhs, depending upon the features it is available. Like if I want only 1D imaging, like the mission which I'm showing on this slide, of course, this is more complicated. So the basic version, which gives you only 1D imaging, resistivity values only. So it costs around 2 to 5 lakhs. There will be equipments like which can give you pseudo sections. I told you what is pseudo sections, like this kind of diagrams. Just a minute, I'll point out. So this kind of diagrams, we say as pseudo sections. This can be generated by the system automatically. No need to bring to the system, like no need to bring to the computer also. There itself you can see whether machine is working or not, readings are coming or not. And this diagram will be automatically plotted by the system, by the machine itself. That kind of machine will cost from 50 to 70 lakhs. And of
so
course,
we have a screen on the machine itself directly.
Yeah. So monitor, it will be having monitor itself with a processing unit. So it will cost around 50 to 70 lakhs, depending upon the company. Maybe Hamel will have a different price, like that.
Okay. So one more question from Mr. Chandrasekhar. What are the limitations of the software? That is, where does data interpretation goes wrong?
Yeah. See, I told you the answer is very simple. It depends upon the expertise of the computer. For example, the system will give this type of graph, for example. And I'm a layman, I don't know. I feel this answer is right. As simple as that, I feel it is correct. I'll give to my client. No, it depends upon expertise. Like what must be the mean square, root mean square value. It's like judgmental value. Like from surrounding site, there may be a possibility of water table, or there is any well, or there is a drainage system by which you can make some guesses. Like this will be sand, or this will be strata, this will be clay strata, like that. So based on this, with expertise and making a good number of iterations and fitting with the theoretical curve, need expertise. If you are good in this, then I feel there is no possibility of creeping any kind of error. If you don't have any good expertise, I think there's something wrong going on.
So your basic suggestion is that taking training or having expertise before going onto the field
definitely
is most important.
Yeah.
So like the next question from Anand, is dipole array the best arrangement for 2D profiling?
Yeah, I told you it's dipole or pole to dipole are recommended for
so it is most recommended one
3D for 3D especially.
Okay, for 3D. No, he's asking for 2D profiling. Is it highly recommended?
Yeah, you can go for it. Like So what is my intention is that especially each method will have their own pros and cons. If you see
Yes,
this slide, pole and dipole, you can see C2, that is conductor 2, is kept at infinity. It depends upon the location. For example, if I take a hilly area, I am doing a like a small case study I'm going to discuss now. So there's a playground which I saw. This one of my like consultancy, like with my experience, I
yes.
got this. So I was doing a survey in a ground. So P1 and P2 are placed perfectly on the ground, and C1 is also placed perfectly on ground. But when I'm planning to go for C2, unfortunately, a hill was coming into the picture. So I have to bypass this because I can't keep my C2 on the rock. It's not so easy to drive a electrode. So C2 had to be placed at a distance very far. Then I recommend pole to dipole because the only option I get is pole to dipole. Because the other three requires a cables to connect. So it's very simple. When the method approach, that is array approach, is becoming sophisticated, like if you see the difference between these, Werner is very simple. Schlumberger, little bit different. Pole, dipole, little bit tough, and pole to dipole is much more tougher. When the toughness is increasing, then the quality of the image goes on decreasing. Like if I ask you, if I want only 1D imaging by pole to dipole, no, the answer is no, you can't do, because the quality of image will decrease drastically, and we can't use pole to dipole for 1D. For 2D, you can go for 4 approaches, but again, the quality of the image gets reduced. If you want the finest quality, better quality of the pseudo section for pole to dipole, then the recommended is 3D. 2D, you may get the image, but clarity of the image goes on reducing.
Thank you, sir. And one more question is, so all these methods and basically ERT is like how much depth we can use? I mean, up to which depth we can use these all methods?
Yeah.
Is there any recommended depth until
Yeah.
which we can use?
This is very common question I always encounter, but very, very interesting question. The answer is very simple. It depends upon the mission. Like as price increases, the depth will also automatically increases. But especially, there are two logics. If depth is increasing, then the image quality will decrease. First option. Second option is that generally majority of the equipments, maybe manufacturing may be different. The depth of exploration will vary from 1/3 to 1/5 of the lateral span. What is my intention is that, for example, if you see this Werner array, the distance from A to B, say 100 meters. The distance from A to B is 100 meters because A and B are extreme electrodes. Then the depth of exploration will be 1/5 of this span. That is A to B is 100 meters. So 1/5 of this, that is 20 meters. So it can give up to a depth of 20 meters from ground level. Some missions are designed for 1/3, like 33 meters, because 100 by 3, 33.33. So some missions are designed for 33.33 meters also. So the lesser the depth of penetration, the better will be the quality.
And maybe with respect to like as you are saying that costlier equipment, can we go for more depths?
Yeah, definitely. That will be one of the parameters I told you, right?
Okay.
So a mission of 5 to 10 lakhs will give up to like hardly 1/3. Sorry, 1/6. Whereas a mission of like 40 to 60 lakhs will give a clarity image of 1/3.
So what are the general precautions that we have to take during the?
So coming to general precautions, so we're working with current. So ensure that there is nothing which is going to electrocute you. So especially before we go to the site, there are set of guidelines given by ASTM code, which is already written in ASTM code. So if you want reference, you can go through that. Like we have to, very common, we have to wear shoes and we have to keep placards so that nobody should enter, because we're working on current and voltage. So we should be very safeguard against this. And especially, I want to tell this point also at this point of time, because now the trend have been shifted. See, so many people may have it out, especially the software itself, you can see, is having something called DC resistivity sounding. But some equipments like present in US countries will provide AC current also, but with a low frequency. So this test can be done using DC current and as well as AC current with a low frequency. So regarding the precautions are concerned, I personally recommend better go to and refer to ASTM code, in which everything is described in detail.
Yeah, can you like say that which code is that, if possible?
You can go to my references. Yeah, you can see the first one, ASTM D643118 is a code like in which everything is written in detail.
Okay, so yeah. So in Indian, I mean, like we don't have any
India you have a code
IS
book.
code.
Yeah, you can see, India you have a code book that is 15736 2007, which is again like reaffirmed in 2012. It's a code book in India code book. You can go through this also.
Okay.
So I think,
But
are there any
small
more questions? Yeah.
Can we get any physical properties of soil by using these methods, or only the classification and with the locations and all?
Sir, physical properties are interlinked. For example, like I'm showing this. I'm sir, actually I didn't understood you. Physical properties means what kind of properties?
Physical properties means like strength of the soil below the earth.
No, I understood. You want soil properties. Yeah. So
like that. Just like we will calculate the SBC for the soil, right?
Yeah.
So,
I understood, sir. I understood.
Basis of SBC.
Yeah, I understood. So this is one of the area where like the world is running towards. So this method or this approach will give only the type of soil which are present below the ground level. Properties are related. No, we can't get any properties from this method.
So we'll get only the classification.
Yeah, it gives only a rough image of what kind of soils are present below the ground surface.
Without digging, you can easily see.
That's what I started with. It is a NDT test, non-destructive. So that's the only intention of this method. So that's why I'm telling this method can be done with an expertise person, because a geotechnical investigator with good expertise can make a comment by seeing the surrounding site or surrounding environment. You can make a comment. A layman going to the site and seeing the readings and saying this is safe is not recommended.
So, if possible, can you share some live examples or live cases that you have seen, if permitted? Like maybe.
Right now, I don't have any screenshots.
You can just explain or
share
something.
at this point of time. But I'll discuss. Yeah, I'll discuss some of the case studies. So one of the case study I encountered is in Bangalore, where I found very hard soil strata. Like at the depth of 1 meter, I found very hard soil. Like I say, stiff clay, better. Stiff clay. The first problem I encountered is that the electrodes cannot be driven so easily. Like to our common sense, I cannot drive my electrode in a rock. This is the first encounter I faced on the site. Second one, once the test was completed, pulling the electrode from the ground is also the one more problem. It's not so easy because we drive the electrode into the ground for a greater depth. Roughly like 1/3 of the length of electrode should be driven into the ground. So when I'm trying to pull the electrode out, it is stiff. It's not easy to pull. So some people don't know. So out of unintentionally he pulled, but unfortunately current was transmitting because we were doing for a stretch of 250 meters along lateral direction. So I think 250 meters is very long when you're doing for a long stretch. So we are busy with someone noting the readings. So some person with intention or unknowingly he pulled the electrode out. At the time, the mission was commanding that electrode to be a current electrode. So finally, luckily, we were working on very low current value. So he got a little bit shock. So this have to be discarded. Like we should be very careful with this. So this is one of my case study, I feel. Like this, yeah. Tell me.
No, yeah, you can continue. Sorry.
So this type of things is also part of precautions. Then we came to realize that placards is also necessary because all the time we can't guarantee how the people mentality will change. So we should be very careful when doing this type of test. And we were validating the results with some other latest trends available in geotechnical aspects. As I was discussing, 2 or 3 names: GPR, MASW, SASW. There are some advancements which India have to be known in upcoming days. These are related to soil dynamics, which I don't want to discuss in this current topic. So we were validating the results of both the tests. So this requires expertise. So my personal experience is that understanding geophysical methods is different at UG level, and executing the same thing on a global scale or on a site is beyond the curriculum. Yeah.
Yeah. So I hope that is the end of the questions. So thank you very much, Mr. Sai Lakshman. Now I request Dr. Venu sir to speak few words about the speaker and the presentation.
Sir, can you talk before the before the sir speaks?
Sure.
So I thank HOD Dr. Vamshi Mohan sir for giving me this chance to come on this platform, and I thank and congratulate all the team of IARE to share my knowledge with all esteemed people. Thank you, sir.
Thank you, sir.
So thank you, Mr. Sai Lakshman. You have enlightened so many things, NDT tests about the geophysical methods and electrical resistivity tests on geotechnical applications. As you told, this might be not covered in the BTech, but we can explore these areas. Even for research purpose also, we can explore these kind of things, right?
Yes, sir. Yes, sir.
So you have enlightened us by sharing your knowledge, and we are very much thankful to you to be a part of our faculty development program. So global trends in civil and infrastructure engineering. And thank you very much for your busy schedule. You have accepted our invitation and came forward. Your busy schedule. So thank you very much for your cooperation. And as department is concerned and college, we will be very thankful to you be a part of our FDP program.
Thank you, sir.
Success. Yeah. So you can take out Sai Teja.
Yes, sir. Sir, thank you so much, Venu sir. And once again, we thank Sai Lakshman sir for sharing maybe the exactly current trends, whatever he's going on in the around the world, and sharing that data with us, and also patiently answering all the questions and linking them with live examples and all. If you don't mind, one of the participants has now raised their hands. We'll take the question, maybe the last one. Madam Jeevana, sorry, she has again raised down the hand. Okay, anyway, thank you, Lakshman sir. We hope that you can continue now because like there is one more session coming on. So you can, if you want, you can join that session.
Thank you, sir.
Yes. Now, Sudhir sir, you can take over.
Sir, we are very thankful to you, Mr. B. Lakshman, sir, for readily accepting our invitation. And on behalf of a whole team of GTCIE and as well as Department of Civil Engineering, IARE, I would like to thank you very much for spending a valuable time with us and sharing a valuable information with us. Not only, sir, I also thank each and every participant and as well as the resource persons for showing their huge interest towards this program and as well as their kind cooperation towards the success of this program. Once again, I thank one and all who make a grand success for this program. Now, I request Mr. Hemant Sai Kalyan to introduce the next speaker.
Thank you, sir. I take this opportunity as an honor to introduce our next speaker, Dr. M. Bhagyaraj. Dr. M. Bhagyaraj is an assistant professor presently working in the Geology Department, College of Natural Sciences, Debar Berhan University, Ethiopia, and is a faculty member there since November 2017. Dr. M. Bhagyaraj was awarded PhD in the year 2014 from Annamalai University, Chidambaram, in the subject of Applied Geology, Remote Sensing and GIS Environmental Management. The thesis was entitled Integrated Terrain and Resources Analysis for Environmental Management of the Kodai Hills, Tamil Nadu, using remote sensing and GIS. He has more than 10 years experience in teaching and research development and also in industry. He has published more than 20 research papers in reputed international and national journals and conferences. His interest in remote sensing and GIS and also in engineering geology is evident from his research areas. From 2010 to 14, he worked as a junior research fellow in DST project WAR Swirls, Sea Water Intrusion Research Investigations to develop remote sensing based land information systems for coastal aquifers adjoining parts of Pondicherry and east coast of Tamil Nadu, India. From 2008 to 10, he worked as a project fellow in University Grants Commission entitled as 3D GIS project, in which Pro 600 3D software was used to prepare 3D maps. His wide areas of specialization include remote sensing and GIS, in which GIS software installation, GDP creation, georeferencing, feature data creation, spatial analyzing, thematic maps, layout creation. He also has expertise in mining industry, petroleum industry, and survey. It is our pleasure and privilege to have a person of your stature, sir, to deliver one of the lectures in our faculty development program. Your topic of role of civil engineering geology in civil and mining industry is exactly what our faculty development program, Global Trends in Civil and Infrastructural Engineering, GTCIE 2020, is all about. We, the Department of Civil Engineering at Institute of Aeronautical Engineering, IARE, wholeheartedly thank you for accepting our invitation and coming forward to deliver your lecture, sir. Thank you.
Can you listen my voice?
Yes, sir, it is audible, sir.
Okay, sir. Thank you for your nice introduction. Good morning to everyone. I'm Dr. M. Bhagyaraj, from Department of Geology, Debar Berhan University in Ethiopia. In these sessions, I'm going to cover a role of engineering geology in civil construction and mining industries. So before start, I have to show some pictures. See, the first one is road damage to shrinkage of soils. The second one is a road constructed on slope was materials with improper protections. After this one is affected for floods. And final one is without proper awareness, the common local people, the constructed building near the rivers. So what is the main reason? What happened to this? What is the problem here? The first image is the whole problems main without proper pre-investigations. That is the main reason. The first image is the lacking of soil investigation. The second one is lagging of slope investigations. And third one is the lagging of hydrological investigations. The final one is the lagging of morphological investigations. So this is the happen. Why this happen means the proper without pre-investigations, the proper without engineering geological knowledges. That's why it will happen. Okay. So these sessions, after these sessions, you shall be able to know about space between geology and civil engineering, as well as some issues related to the mining engineering. You will be able to learn how this engineering geology come into the specialized discipline, and you will understand different engineering geological investigations, and you will be able to know about the different founding grounds, especially in rock masses, and you will be able to identifying the different issues which are cropping the construction industries and during the mining while working with rocks, and will be able to some remedials and measures. The introduction part, as we know that human beings are the youngest and perhaps most intelligent life forms having their surface. The construction started by the human beings. When they face, at the time of constructions, when they face the difficulties of weathers and natural hazards, they have to try to make shelters into the natural cave, into the rocks. They have tried to making them own shelters using the different natural materials present in around them. The shelters have varied from place to place in terms of shape, in terms of size. The materials they have used for the construction depending upon the what climatic fields they are living into. The same designs, the longevity of any civil engineering structures, especially a big one or mega one, need counter different earth system process. So these process, they always act around the structures, which will make also, we have to make those structures strong enough to face those natural processes. Apart from this, in almost all the civil engineering constructions, we need construction materials which come usually different rocks. The few construction materials which will get from the plant kingdoms. As we know that the Earth is a dynamic planet, and it is interacted to the atmosphere, interacted to the hydrosphere, lithosphere, and asthenosphere, etc. To live on this Earth, we have to be an horribly with space, which are important in the present all around the Earth forming operating systems. The studies various discipline of earth sciences helps understanding in this operating system, and the earth science, as you know, cross mainly from many the different sciences, for example, physics, chemistry, and mathematics. Now let's come to geology. The geology, as you know, is one of the major discipline of the earth sciences, which is dealing with the Earth system, apart from geography, oceanography. If work has defined engineering geology, then we can define application of geological sciences to engineering and mining practice for identifying safe location, design, construction, operations, maintaining, etc. The work, anything leading in geology, essentially in the regions where geological process and man-made structures interact with the latter safety as longevity or to be ensured. So broadly 3 aspects can be mentioned here as far as engineering geology concerned. The first one is rock materials, so which is to be used for construction, for example, building stones. Secondly, rock mass, and which is going to find the various structures. Thirdly, endogenous and exogenous geological process which are operating around the construction. Defects on they humble the constructions in 1 week or another present time as well as the future times. So next one is the history of engineering geology. The engineering geology is not a very old art discipline. Even with geology, such as scientific discipline is very old. But engineering geology came as a discipline in 1914. When book was written by Reyes and Watson, 1914, then 1925, Carl Tesahi, an Austrian senior geologist, he is published the first textbook in German language in soil mechanics. He is the father of soil mechanics, but he has a great interest in geology because he was associated with many constructions related to the tunnels in with sweeps faults. He too wrote the book Redlich and Camp, an engineering geology. His most important contribution in 1947, when he gave an engineering classification of rock mass termed as rock load theory. He gave this classification to design the tunnel support systems, and he has identified 9 rock mass classes and different kinds of supports for each rock mass classes. So another group of engineers who were busy in making dam, they have found that few dams have failed. For example, the Austrian dam, Colorado River in Texas in USA, and then San Francisco Dam, California in 1928. These videos, they have to promoted that we should get some basic knowledge of geology to work on such mega engineering projects. Charles P. Berkeley, an American civil engineering and geologist who was considered to be first American engineering geologist, worked on a multitude of engineering projects, and he has studied different dam fluid worldwide. He later worked as an engineering geologist Gordon, he put all his experience into the first ever documents for linking geology and civil engineering in America to continents by writing application of geology to engineering practice, known as Berkeley. This was published in 1950 by United States Geological Survey. So the other group of engineers who are busy and he said, Charles Berkeley, he said that an engineering geologist used to work on the foundation of the structures to give guidance to their civil engineering counterparts, the civil engineers for the safe design. The engineering geology is developed into geoengineering. The geoengineering further development into the rock mechanics. The rock mechanics is a very specialized branch to civil engineers in general, and it has another offshoot, that is the mining engineering. Well, again, we get a lot of information from the engineering geology in rock mechanics. Now, before going to detail of engineering geology, let's have some idea about the civil engineering also. Civil engineering is an amalgamation sciences, art, professional skill, and engineering achievements. The requirement of appropriate construction materials of required specification in appropriate design for any particular structures is an important factor in safety and longevity of civil constructions. As we know that all these civil constructions are made either on the ground, partially inside the ground, or completely inside the ground. They come across different geomorphological and geological process. So that's why we have to have a link between civil engineering, that's earthquake engineering is an independent. In advanced civil engineering subjects, these two need knowledge of structural geology as well as the tectonics for making safe buildings, safe infrastructures in the Earth's areas. Apart from this, we can also include coastal and mining engineering, so which is discipline of civil engineering, but they need an input for engineering geology and rock mechanics. The natural disaster study also requires knowledge of earth sciences in general geology and engineering geology in particular. So engineering geology, the studies can come pictures into different stages. They can come into initial stage, so where we are just planning any structures to be built. We have to work out and logistics. We have to go through literatures which are already available in form of reports, maps, aerial photographs, and satellites images, etc. And we have to work out the feasibility studies. We have to go for cost effect analysis, environmental fact analysis, so on so for us, and initial stage investigation for engineering geology. Then you come to main stage. You have to go for different detailed studies, which can include the geological, a geophysical, a laboratory, and field test. Finally, you come to review stage in concurrent stage. When you have start your construction and which excavations or foundations, you find some new issues, some new problems that has to be taken to the consideration. And then we have to the final stage of our investigation. We have to see that after constructions of your structures, how it is going to last in futures and is interacting with the present day and future geological process. So we can call these to be the forensic basis. As we know that all ground which we are making structures, they are not unstable foundations, unstable ground to exist. Sometimes the situation can always come across because of variable ground conditions, and perhaps also due to investigation. Sometimes we have soft hand settlements. Sometimes we have turbulence topography. Sometimes we have issues related to the land reclamation. Sometimes we have slope failures and landslides, etc. Now, the concentrating in energy for the development of the fine structures in large scale demand of construction methods. We need a lot of power generations, we need a lot of mining industries, tunneling, underground constructions, and large scale excavations, as well as slope stabilizations. All these activities can be done on the earth surface, can be done greater depth with very rare properties in tool phase. Some engineering geology and rock mechanics will act an important tool during the planning. So engineering geological investigation for civil engineering project can be start before the constructions, and we have to assess many different aspects, which include, let us, cost benefited analysis and site conditions and ground properties, probable difficulties, accessibility to site and logistic involved, availability of construction materials and legal and environmental clearance, data generation for designing the structures, etc. For these, we will encase cost which may value from 0.5% to 4% are different projects. For example, road, dam, and tunnel, but we have to invest. We have to invest some amount because of don't invest our investigation. After the investigations, we may have some problems which we result into carrying of more money as compared to what we have left during the investigation. So it has been said that you should pay for investigations whether you have one or not. Now, the ground investigations is to the required, the varied, in particular projects. For dam projects, it will be different. For tunnel, it will be different. For road and railway, indifferent. For small buildings will be different, so on so far. So what issues can be trapped during the investigation? So we may be able to get, we may be able to find unconsolidated, soft and expensive ground materials, we may come across with glacial outwash strut, colluvial and fluvial deposit with various thickness and depth. We may come across weathered, weak and proposedly fractured rocks, outcrop and bedrocks. We may come across old or abundant landfill or mining site. We may cross the shallow groundwater table, cutting or break of confined aquifers, and we may have different kind of slope issues or areas of landslides. So any major projects is analyzed, improved the standard of living society, and not only the involved expenditure, but a lot of time in completions. Before starting any project, we have to go for the detailed ground investigation to know that the proof and bones of these projects. We have to go for excavations. We can go for 3 stages. One is the preliminary stage, main stage, and concurrent stages. The preliminary stage is mostly office work. In your office, you can get a lot of data from different organizations, and you can build up model and which you are going to have the future investigation. Then you go to site visit, see the things which I have seen in your office study, and then you have prepare the preliminary report which can be used for working out the feasibility of the projects. Then in main stage, where we have go to a detailed field works, where we have to carry out the fresh survey and different scale to ascertain topography, geology of the area. Sometimes for some shallow surface informations, we go for excavating trial bit edges and shafts. Deep excavation, deep investigations, we may go for the borehole logging methods and physical surveying, as well as have to collect the lot of samples for the field test, as well as for laboratory tests. Based on this test, we can make the final reports. After having the final report, we can go for the construction. We can start the construction, and during the constructions, we can see any lagging goes beyond investigated. Then we have to make those things as correct. Now let's come to the detailed field studies. So we are the engineering geologist. We have to play the most important role depending upon the nature and size of the project. We go for the detailed investigations which involve the services of a different kind of alignment for a topographic, soil and rock types. We include subsurface exploration to see that how the soil and rocks are extracted downward and what are the variation is comes. We have to find the different kind of discontinuities which may be in between soil and rock. So between the different rocks, we have to see what different kind of continuities and what are the numbers and what the potential of casing problems, so we can have formal excavation. The first it is drill pit and trench, so which can be very shallow. We have to use for 1 meter to 5 meter depth. We can create the small tunnels for tips which can be built up for 5 meter deep into the logs. So we can use the adits and trips to the sample from the inner part of the rocks. As well as we can initiate some instruments we can be used for testing to work out new technical properties of rock masses. You can see this picture. We have shown the pit and trench and drift and adits. These drift and adits somewhat deep topography as well as the rock mass. You can see that how the thick are changing under, or you can put some instruments into the workout from new technical properties. After from this for deeper excavation, so we can go for the borehole drilling. Has been covered and different models, this geology paper. So I am not going to the detail of the drilling, but what is important as far as the engineering geology is concerned, we go for working out your parameters called as the core recovery percent or rock quality designations. For these, depending upon the project, the beginning of the project, we can go up to 50-meter depth. Most of the civil engineering structures, they are not beyond this depth. So what we'll do, we're taking the drilling system, double barrel diamond drilling systems, which can be drilling to the rocks. We use the rotary drilling systems can bring out the rock cores or 54 dia called as the NF size. We have to parameters core recovery percent, rock quality designations. So you can see the drilling machines. Here is being the drilling through the rock. This will bring out the rock cores. The rock quality designation is extensions of properties that core recovery percent is defined total length of core recovered. In drilling operations, for example, do you have the drill of 50 meter? The total core, it is how the come 40 meters. Then core recovery percent is 40 divided by 50 into 100. That is the 80% of core recovery percent. The rock quality designation is almost the same. But here what we do, we take only those cores which are more than 10 centimeter in the land. So RQD will always less than the recovery percent. RQD can give a very good idea about the character of the rock mass. So you are getting the RQD more than 90%, that rock mass is excellent. This is the rock quality designation tables. See, the greater than 90% is excellent. 75 to 90% is very good. 50 to 70% is good. 25 to 50% is poor. Less than 25 is very poor. So what exactly the RQD is done? So what is the perceptions behind this parameter? The perceptions closer you have joined, more you have share shown, what core recovery as well as the RQD is very less. That you know about the condition of the rock deeper in the ground, RQD is going to be very important for the aspects. Then go for geophysical exploration. Geophysical carried out the thickness of overburden, depth of bedrock, the presence of weak zones, groundwater potential, rock mass explorations. So we have the different methods we have to use for excavation, gravity methods, electrical resistivity methods, magnetic method, and seismic methods. So we can use any of these methods of different method together to get the subsurface idea of the deeper part of the ground surface. After getting these investigations completed, will clap all the informations together. And we will come out the working model of the area, and then we can put this working model for designs of the structures. Now we have to summarize. The geology provides the systematic knowledge of construction material, is concerned the compositions in other physical mechanical properties. The knowledge of geological work of the agencies such as river, geological, wind help to planning, carry out the major projects. Some stock events causes by earth process, for example, landslides, volcanisms, earthquakes, and cyclone, the need to well understand in terms of phase occurrence as well as magnitude to save human construction for the human achievements. The knowledge of groundwater system also one of the important things about the quantity of the occurrence, the consolidated and unconsolidated information is needed, and also water supply irrigations and excavations may others need their projects. So before starting any engineering projects at any place, we have to detailed geological report followed by the geophysical investigations. Detailed geological or mining geological investigation is very important for the construction activities. And also
Sorry for the inconvenience. Maybe there is some network issue with the speaker. So it will be resolved soon.
Participants, very sorry for your inconvenience as the speaker is out of country, that is he is at Ethiopia. Since we know that there may not be any proper facilities, he is having some electrical problem. Maybe the power was gone at his side. So just we are trying to get him back. Thank you for your cooperation.
We are extremely sorry, participants. Now, the speaker is facing some internet facility problems due to power cut at his place. So until that
Our world is undergoing changes. changes that have a significant impact on our environment. Changes that force us to think in new ways. This also applies to buildings. A study on the future of building technology shows that requirements are undergoing lasting changes. The need for security will play an even greater role in the future. Flexibility and dynamics will be basic requirements for system operation. Maximum efficiency will have top priority, and not only where energy is concerned. In addition, we need to increase comfort for the well-being of users. Only solutions which create the greatest synergies between energy efficiency, comfort, and safety and security will be sustainable over the long term. Solutions that turn buildings into living organisms, networked, intelligent, sensitive, and adaptable. Modularity is one key. Solutions that easily adapt to the changing needs of their operators and users. We achieve maximum compatibility using standardized interfaces. Plug and go. The modules themselves must be flexible as well. Space is divided as needed, assisted by mobile equipment that integrates seamlessly into the logistics concept. A giant step forward toward greater efficiency. Because flexible usage is suddenly possible over the entire life cycle. Transportation systems will also be more flexible. Route usage will be optimized, divided into passenger and cargo flows. Destinations will be reached faster, and security-critical areas will be better protected by dynamic route management. Along the way to the future, we will network classic domains completely and intelligently, and we will create synergies that make new functions possible. Energy example. We will no longer focus just on energy distribution. An intelligent energy management system will control the interplay between internal consumers, producers, and the energy mix of public power grids. New types of storage concepts will make it possible to purchase excess energy from the grid at competitive prices. Energy that enables load peaks to be equalized safely and efficiently. Increasing water treatment requirements also offer potential in the truest sense of the word. Additional energy storage is possible through intelligent networking. Consumption optimization will, of course, also be key. New types of functional construction materials and techniques offer potential in the areas of lighting and climate control. However, the possibilities cannot be fully realized until they are integrated into the building management concept. Intelligent networking of disciplines creates outstanding synergies where security is concerned. Discrete access controls according to the open door concept not only increase security, but also allow for dynamic logistics. People are guided quickly and safely to their destination through personalized assistance. A wide range of control and navigation solutions point the way comfortably and at the same time improve discretion in defined building zones. In the future, we will monitor all media flows, including supply lines. And safety measures will be initiated automatically as needed. Intelligent networking provides maximum security. occupancy sensors in the lighting system do more than just turn the lights on and off. In an emergency, they also assist in organizing a fast, orderly, and thus safe evacuation. Escape routes are defined according to the situation. Lighting installations operate in emergency mode and point the way dynamically. Acoustic signals and voice prompts provide additional support. Subsystems support the evacuation scenario. Intelligent systems help detect flows of people and separate them when escape routes are about to become overloaded. Intelligent use of installations and networking with the surrounding area allow for information to be exchanged in real time. Only when all systems work together in a network can we meet the security requirements of the future adequately and efficiently. A networked, integrated, and intelligent building management system will be at the heart of the next generation of smart buildings. A building management system for greater efficiency, comfort, and security. On the way to sustainable cities, we are already using our expertise in building technology and the architecture of network systems to connect buildings into building clusters via an IT backbone. And we are achieving significant improvements in energy efficiency. Smart grids and smart consumption will shape the future. Networking city districts and even entire cities will also mean more security. Security that growing urbanization urgently needs. Intelligent, sustainable solutions will shape the future. And the future has already begun.
Dear participants, we extremely regret what has happened. The speaker, Dr. M. Bhagiraj, is facing problems at his end in Ethiopia. We tried to resolve the problem, but it is very uncertain of his returning back. He might come, but we cannot keep you guys waiting for a long time. So, with extreme apologies, please, this is the end of today's session. In all possibility, we'll try to accommodate the same session tomorrow if the planning is done well. And as of now, tomorrow's schedule is as per as it is. There will be 2 lectures in the morning session. If Dr. Bhagiraj is fine with all the facilities there, maybe tomorrow afternoon we can have this session. As of now, it is uncertain, but we will intimate you whatever it is through the WhatsApp groups or mail. And As you know, the feedback form for today has been put in the chat box. Please check it out, or else the feedback form will be sent into WhatsApp groups. We sincerely apologize for this mishap what has happened. We hope to rectify it soon and not repeat it in all possibility. I thank you for your cooperation, and this is the end of the session for today. The feedback form is in the chat box, and the same will be provided to your WhatsApp groups too. Please feel free to fill that form.
One more thing, we'll thank Dr. Bhagiraj for sharing his valuable ideas. And we are apologize once again. So if possible, we'll arrange the same session tomorrow. Just like told, our colleague told. Thank you very much, Sir Bhagiraj sir, for you also. We are very grateful to you here on this FDP program. So thank you very much.
Thank you, sir, Dr. Venu. So this will be the end of today's session.
So we'll meet tomorrow by the same time, today's time, right? 9:45 or 9:50. So Hemant, you can take it.
Yes, sir. Yes, sir. Yes.
We can close
Okay.
today's session.
Okay. Thank you all for your cooperation. Thank you, Dr. Bhagiraj.